Welcome to this channel. Today, I would like to discuss regarding confidence interval. We know inferences about a population are made from the information gathered from a sample. That is, samples are used to estimate population parameters. Population parameters, example, mean, standard deviation, proportion, etc. Before discussing confidence interval, it is good to know about estimation, point estimates and interval estimates. What is estimation? Estimation is making inferences from a sample about a population, that is about an unknown population parameter. Process of making inferences about a population from the sample. There are two types of estimates, point estimates and interval estimates. What is point estimate? Point estimate is a single value used to estimate the population parameter. It involves calculating a single statistic to estimate the population parameter. Sample mean is a point estimate of the population mean. Same way, sample standard deviation is a point estimate of the population standard deviation. I will explain this with an example. If a study is done to assess the or to estimate the weight of students in a class. If we take 10 students randomly from a class of 100 students and found that their mean weight is 55 kg. This 55 kg, mean weight of 55 kg is considered as the mean weight of the entire class. That's a single value obtained from the sample and used to estimate the population parameter. That's the point estimate. Next is the interval estimate. From the term itself, we know it is in the form of interval, that is range. Range of values where the population parameter is expected to lie. Here there is an interval of values. With interval estimation, confidence interval are constructed. Confidence interval Ci. So, in the interval, there is an upper limit and lower limit. These are called confidence limit. Now, we can discuss on confidence interval. Confidence interval are range of values used to estimate a population parameter. So, it's an interval, upper and lower values are there, range of values are there, used to estimate a population parameter. It's an indicator of measurements precision. It's an indicator of measurements precision. That is, how close your measurements are to the original estimate if you repeat the experiment. It is a probability that a population parameter fall between two sets of values. It's mean of the estimate plus and minus the variation in that estimate, and measurement that shows the level of certainty for a sampling method. When a population is repeatedly studied using multiple samples, the mean value obtained for the variable from those observations is equal to the true population mean. For example, to study the height of preschoolers, multiple studies are done from the population of preschoolers. The figure shows the population of preschoolers, and multiple samples are drawn to study the preschoolers, to study the height of preschoolers. The average mean height reflects the population mean height. So, for each sample, the samples are drawn randomly from the population. Each set of sample, the mean height is there, and the average mean height reflects the population mean height. Then, the confidence level. The width of the confidence interval depends on variation in the population. That is, whether the population is heterogeneous population or homogeneous population. The width of the confidence interval also depends on the variation in the sample. The sample size affects the width of the confidence interval. The size of the sample also affects the width of the confidence interval. Greater variability in the population leads to wide confidence interval. The confidence interval is computed at a designated confidence level. Confidence level is the percentage of times it is expected to get close to the same estimate if the study is repeated. That is, the probability that value of a parameter falls within a specified range of values. For confidence interval calculation, confidence level is needed. That is, confidence interval calculation is based on confidence level. The confidence levels are expressed as percentage: 90%, 95%, and 99%. These are the confidence level set to calculate confidence interval. The 95% confidence level is mostly used. The 95% confidence level is mostly used. The width of the confidence interval, already we have discussed, is based on the population and sample variation. And confidence interval calculation is based on confidence level, which is expressed as percentages. The confidence level and Z value is shown in this figure. For the 90% confidence level, Z value is 1.645. For 95%, it is 1.96. And for 99%, it is 2.576. So, the confidence level, the Z value of the confidence level should be known to calculate the confidence interval. The formula for confidence interval calculation is CI equal mean plus or minus Z into standard error. That is, standard deviation by root n is the standard error. CI is the confidence interval. X bar is the sample mean. Z confidence level value. S sample standard deviation. And n equal sample size. 95% confidence interval means if the study is repeated 95% of the time, the results obtained will match the results obtained for the population. That is, if confidence interval with 95% confidence level is constructed, it means you are confident that 95 out of 100 times the estimate will fall between the upper and lower values specified by the confidence interval. This I will explain with an example. If we estimate the height of children in a class, the mean height of 50 children is 100 with a standard deviation of 2. Confidence interval is calculated at 95% level. For 95% level of confidence, Z value is 1.96. So we have to substitute the Z value of 1.96 in this equation to calculate 95% confidence level. By substituting these values in the formula, mean, that is 100, plus Z value for 95% confidence level is 1.96 into standard deviation 2 divided by n, sample size is 50, root of n, that is root of 50, that is equal to 100.56. For mean minus Z standard deviation by root 10, it is 99.44. So confidence interval is between 99.44 and 100.56 with a confidence level of 95%. Same way, we can calculate for 90% as well as 99%, substituting the value for the Z value for this. So 99%, the Z value is 2.576 and the confidence interval is calculated substituting this value in the formula. Thus, confidence level and confidence intervals are measures within statistics. This indicates the certainty of a sample being a good representation of the whole population. So, this confidence interval makes sure whether the sample chosen is a good representation of the whole population. Hope it is clear to you. Thank you.